Thank you very much. Okay, everyone, let's get started. So good afternoon or good morning, depending on where you are, and welcome to Thorogood's Azure Synapse Analytics event. Before we start, let me introduce myself quickly. My name is James Leonard, and I'm a Senior Data and Analytics Consultant at Thorogood Associates. And with the help of my colleague, Andrew Kennedy, we'll be taking you through today's session on Synapse Analytics. So let's go through the agenda for today. So first of all, we'll start by looking at a quick overview of Thorogood. Then what we'll do is spend some time introducing Azure Synapse Analytics and its evolution from Azure SQL Data Warehouse. Then what I'll do is introduce our use case for the day, which we'll then use to walk through the various components of Synapse Analytics, showing how it can be used from initial data discovery right through to productionization of our data and analytics solutions. Finally, we'll wrap up the session with the next steps on how you can get started with Synapse Analytics. So for those of you in the room who aren't familiar with Thorogood, we're a specialist data engineering, data science, and data visualization consultancy with over 30 years of experience delivering data solutions to leading enterprise organizations. The solutions we deliver are still based on our founding principle. That is, by always locking onto the business goals and then unleashing the technical and analytics capabilities, we can maximize the opportunities from those business objectives. We maintain this business focus across a range of delivery areas, so right through from initial strategies and roadmaps, proof of concept and pilot delivery to the full solution implementation and wider rollout of those solutions. We do this by not only maintaining the tools that we create, but empowering individuals and the organizations they work for to use them. We do this with the help of our technology partners, but we are an independent consultancy, meaning we don't partner with just one vendor, but we work with the best of breed technologies in the business intelligence and analytics space. Having said that, we are talking about a Microsoft product today. We are a Microsoft Gold partner and have been for nearly 20 years. We're a Gold partner in 5 competency areas that are pretty relevant to the content that we're going to cover today. Finally, we do run a wide range of educational marketing sessions like today's event. We have an active marketing calendar, which I hope you guys are aware of, that covers everything from the latest releases in Azure, industry-focused use cases for advanced analytics in tools like Databricks, through to how to run things like a data-driven organization. So with that, why don't we get started and take a look at Azure Synapse Analytics. So before we delve into Synapse, I just wanted to really illustrate some of the drivers for Synapse. And something we used to talk about quite a lot are the goals of a modern data architecture. I still really think this is relevant today, and especially as more and more companies become data-driven. So what are those drivers? So now we have more data than ever. So we have larger volumes. We keep seeing it in the press and news that the kind of data volumes are increasing more and more, and we need new and better ways to analyze those. Because we have different types of data, so structured, unstructured data, potentially social media, for example. Maybe we want to analyze things like tweets. We need a way to store and analyze this information. And that kind of brings me on to the second point, so analytics. The ability to analyze these new data sets with those ever-increasing volumes, but also enabling people to become more data-driven. So everyone within the organization being able to perform the analysis they need to drive the value from our data assets. And then finally, agility. And I kind of mean this in 2 ways. So I'll start with the first one, agility for people. We need to be able to analyze new data sets in a matter of hours and maybe days at most, not taking 6 months to get new data into our warehouse, for example. So ingest data, analyze that data. But also, as we're all well too aware, that over the last year or so now, the environment that we operate in changes an awful lot. So we need flexible platforms that can change with us as we need to change as quickly as possible, if things like COVID, etc. as well, but also changes in our business logic. Maybe we want to push e-commerce in a consumer goods example. So we need the agility to do that. And that's what we want from our modern data platforms. And these are really the goals that Synapse was designed for, to meet these ever-changing and more challenging needs of the business and to perform deeper analysis. But the big thing we'll focus on today is in a seamless experience. So what Microsoft have done with Synapse Analytics is brought together a lot of their core components within Azure into a single tool with an integrated user interface. And this consists of 4 key components, or I've boiled it down to 4 components for the purposes of today. So Synapse SQL, a complete T-SQL-based analytics engine for us to create both productionized packages, so to load our data on a regular basis, but also perform exploratory analysis on our data as well. And there are two aspects to this that we'll explore in more detail later on. So SQL Pool, which is really our iteration on SQL Data Warehouse, but also SQL on Demand, a relatively new feature that within Azure that allows us to run powerful ad hoc analysis over our data, and we only pay for the data that we're processing as well. The second thing I've got on here is Apache Spark for Synapse. So integrated Spark-based notebooks that allow us to perform large-scale data transformations as well as analytics in a variety of languages. And again, we'll discuss this a little bit more later on. The third thing I've got on here is Synapse Pipelines. So this is really our kind of hybrid data integration tool. And for those of you familiar with Azure, it's essentially Azure Data Factory. And what this will do is allow us to orchestrate and productionize our data pipelines. But it will do this with very close integration with the other Synapse components as well. And then finally, Studio. So the thing that really brings this all together is essentially the wrapper that allows us to access all of these components in a single place. So just to go a little bit more technical, but only a little bit more technical, what does Synapse look like under the hood? So at the base, Synapse Analytics brings together multiple sources of data. So that unstructured and structured data, potentially from our on-premise environments, cloud environments, devices, maybe the streaming of those tweets in the example I used earlier. So really our big data requirement. And for that, it's underpinned by Azure Data Lake storage. So Azure Storage, an area where we can store all of that data. Crucially, it then allows the integration, management, and monitoring and securing of these data sets under what we call kind of a unified experience using familiar kind of systems like SQL and also Apache Spark. With this, we also have tight integration with the other Microsoft and actually non-Microsoft components that will allow business users to make more informed decisions at a much faster pace. And it's really in this way that Synapse makes it easier to bring our organizations together by helping them securely collaborate, share, and analyze data, all within this single environment, while being able to run whatever type of code they want with those two different kind of SQL and Apache Spark runtimes. What I want to look at now is Synapse Studio. So our kind of lens to all of this, our interface to get to all of the components. And Synapse Studio fundamentally consists of 5 areas. So I've color coded these. Three are shown in green, and these are really aimed at kind of helping us with our analysis journey. So first of all, we have the data. So the ability to see all of our enterprise data in one area. We then have the develop area, and we'll look at these in just a second. That's an area where we have access to those different runtimes. So access to SQL, access to Apache Spark, but we also have access to a couple of other things that we'll briefly touch on in the demo in just a second. Then finally, orchestrate, the area we go to create those data pipelines to automate our system. And then those shown in gray, that's really around the maintenance of the Synapse environment. So the ability to effectively manage and monitor that entire environment. So with that, let's have a look at Synapse. And what I'm going to do is just switch over to the browser interface. And for those of you familiar with Azure, we would access Synapse in the same way we'd access really any Azure component. So here I've just gone through the Azure portal and clicked on the Synapse workspace. And what we have here are the standard things that you would expect. We can manage our security from here, so on and so forth. The thing we're going to focus on, though, is this workspace web URL. So we can go to the Synapse workspace. And when I enter the Synapse workspace, we come to the home screen. So we'll come back to those components I was showing in just a second. And we have a number of options to really get started within Synapse Analytics. So for example, if I wanted to ingest some data, I could click ingest and we could run through a pretty friendly user interface/wizard to ingest that data into the Synapse environment. It's also pretty useful because it shows all of the things that I've been using recently. So you can see when I got everything ready for this event today, half an hour or an hour ago, and we can see everything that I've been playing with over the last few days and couple of months as well. But what we're going to do now is look at the other areas. So along the left-hand side here, a pretty simple to use navigation pane. So if I click on data, this is where we go to see all of our enterprise data. So focus on the left-hand pane, ignore everything on the right for now. And we'll run through this in a little bit more detail, but we can essentially go into this data view to access all of our data in this left-hand pane. If we want to access those SQL runtimes and Apache Spark runtimes, we can go to the Develop tab. And here you have the options to create SQL, we can create notebooks, we can create data flows. So I'll kind of show data flows very briefly here, the ability to create simple point and click ETL, and also Power BI. So Power BI is also available directly within Synapse Studio. The second thing to look at is the integrate area. So essentially that orchestration, creating data pipelines that we can use to orchestrate all of those SQL components and Apache Spark runtimes as well. So these are the three kind of key areas that we'll be focusing on when we look at analyzing our data. From a management perspective, we can monitor everything that's taking place within our Synapse environment. So I can see all of the SQL requests. So these are all of the requests that I've triggered over, I guess, earlier today, like at the duration, how much data has been processed, so on and so forth. We can look at all the pipeline runs, so on and so forth. So there's quite a lot we can see here if we want to monitor what's taking place in our Synapse environment. I also have this manage area. So manage area here allows us to essentially manage those runtimes. So I can look at my SQL pools, built-in is running. My SQL pool, so my data warehouse, isn't running. I'm going to start that. So I'm just going to hit the play button there and we'll resume that data warehouse because we're going to need that in a second, or should I say SQL pool. And we can do the same for Apache Spark as well. So we can see what we've already got set up, a small Spark pool running in the background. So that's our very high level overview of the, I guess, the components within Synapse Analytics. And I promise you over the next kind of 15, 20 minutes or so, you'll get pretty used to those different areas. But what I want to do is just have a look at our use case for today. So what we're going to use to put the analytics runtimes, the SQL runtimes to the test. So for today's demo, we're using a big data set looking at US flight data. In this data, we're able to see things like the origin and the destination of all the flights for the US, where that flight was going, what airline was operating the flights, and any delays as well associated with it. We also know that COVID-19 has dramatically impacted the airline industry. So what I want to do for this is perform some analysis to see what type of impact COVID has had on the number of flights in the US. To do this purely from a data perspective, we have data for the last 25, 26 years. This is all kind of provided in CSV files. So for recent years, we have all of the latest months of data. For historic data, we have a single file per year, and we're going to use that to analyze a couple of things around flights in the US and then look at the impact that COVID's had on those flights as well. What I want to do is look at, I guess, the components for how we can use Synapse to work with our data. So in Synapse, we have a number of options to store our structured and unstructured data. And the first one I'm going to highlight is SQL Pool. And as I've kind of said, as you probably noticed, I've mixed my words a little bit at times, is essentially SQL Data Warehouse. So for those of you who don't know, SQL Pool builds on Microsoft's long-standing relational database, SQL Server, the industry's top-performing SQL engine, offering comprehensive support for the SQL language. With SQL Pool, we can run analytics on petabyte-scale data backed by Azure Premium Storage. This analysis that we'll be able to run will be highly performant and leveraging that parallel data warehouse architecture. We can make this performance flexible and scalable depending on our use cases. So we have things like intelligent workload management, but also the ability to scale up our compute power either up or down in a matter of seconds. We can flex this to fit our data needs. So whether it be structured or semi-structured, we can store this in the warehouse for best performance, or potentially as well build it as a view directly on our data lake for greater flexibility. At the same time, SQL Pool offers industry-leading security with over 50 government and compliance certifications as well. So how does SQL Pool achieve this? So well, at its core, as I said, SQL Pool is built on the tested and trusted SQL Server technology. But behind the scenes, it stores all this data in a collection of SQL Server databases, in my mind, essentially bolted together. This means the data is partitioned and can be read in parallel. And that underpins the ability to run fast queries across large volumes of data, although as we've see a little bit more later on, Microsoft will continue to build extra features on top to increase that speed. But the magic behind the scalability of SQL Pool is the separation of compute power from storage. So you're able to ramp up the power when you've got your heaviest workloads, for example, or maybe your important urgent queries, and then scale it back down, say on evenings or weekends when the load is lighter. And then depending on your use cases, if there are times you're not going to use SQL Pool at all, you can pause it. So I pressed play earlier, but before this it was paused completely because we weren't using it. So at every point in time, you're paying for what you're using. So essentially we can pay for the highest compute power at peak times without having to commit to pay for all the compute nodes at points when you know you only need the storage and you're not going to be running queries. So this is essentially where we're going to want to store our most on-demand data. And in this case, that's where we're going to be storing our current data. So maybe the last 10 years worth of flight data. But in our use case, we also had some archive data and we need somewhere to land that current data as well. And this is really where the other storage options in Synapse Analytics come in. We have the option to connect to a variety of other data sources that are categorized in Synapse as external data or data sets. So external data, these are typically our other Azure data storage options. So that includes direct integration with the likes of Azure Data Lake Store Gen 2 and also Azure Blob Storage, as we'll see in a second. From a data set perspective, we also have the option to connect to data in a multitude of other source data systems, and that's both Microsoft and non-Microsoft. So for example, we can connect to AWS's Redshift as well, or IBM's DB2. So a pretty wide range of flexibility to bring all of our enterprise data into one area. So let's have a look at this in a little bit more detail. So what I want to do now is use that data area to really start exploring the data that we have within Synapse. So from a workspace perspective, this is where we'll have our SQL Pool. So that SQL Pool running, we've got a number of tables. You can see different icons because this is essentially showing how we partition the data. So this is being stored across all of those different SQL databases under the hood, so on and so forth. We also have the options for linked data. And if I look directly at linked data, we have Azure Data Lake Store, so underpinning Synapse, also Azure Blob Storage, and then those integration data sets as well. If I press plus, it's pretty easy to add these new resources. So if I connect to external data, I get the options that we saw. So Azure Blob Storage, Azure Data Lake Store Gen 2, and some other Azure components. If I also want to connect to something outside of Azure, then I can go to my integration data sets and we can see that full range of what's available to us. So some Azure pieces here, but also we have IBM's DB2, so on and so forth, FTPs, whatever we may want to connect to. We're pretty much able to do that with Synapse Analytics. But let's have a look at some of the data that we're going to use for the analysis. So in Data Lake Store Gen 2 here, we've got an airline container. If I go into airline, you can see I've already filtered to there, but we'll go back up. We have our current and we have our archive data, and we also have some COVID data as well. So in archive, as I said, if I drill into that, we'll see we have a data file for all of the historic years going back to 1987. If I go back up, we can see current, we have folders for each year, so 2009 to 2020. We don't have 2021 data in here yet, but if I drill into 2020, you can see we have a folder for every month of the year, and within that, a CSV file. If I drill into drill back into December 2020, we can start doing some previewing of the data. So what does this look like? One-time reporting, not very descriptive. But if I look at a preview of that, so where we've landed the data, we can get some insight into the data that's available within these CSV files. So we have the date of the flights, we have the carrier information, tail numbers, origin, airports, and codes. So quite a lot of kind of IDs here, but we do have the master data to support this. And then a little bit more information on the distance that the flight was, so on and so forth. And we can also play with things like the column header, turn that on and off just for easier analysis. So what I'm going to want to do later on is ingest some of this data, so that current data, into our data warehouse. And to prepare for that, I guess this is going to be a moment of peak activity. So I wanted to also show the scalability. We looked at how SQL Pool, we can ramp up that compute up and down, but what does that look like? So this is the only time in today's session that I'm going to move outside of the browser interface. I'm going to move to Management Studio. And here I can run some control queries. So here my first query essentially shows the power of, it shows a little bit about the current SQL pool. So we can see we've got a SQL pool, the data warehouse, DW100C. So that's essentially the compute power. If I want to increase that, so getting ready for the queries that we're about to run, I can change that to DW1000C and just run a very simple alter database command. So I'll hit F5 and that's executed. So now in the background, if I just look at my operation status, we're essentially altering the database. That's in progress. So it's now scaling the SQL pool in the background to increase the size or increase the level of compute that we have available. So before we do that, why don't we talk a little bit around how we're now going to analyze some of that data in the data lake. And here we're going to start talking about develop. Potentially I want to do some exploratory analysis of the data in the data lake to see what I want to load into my SQL pool and potentially start gaining some initial insights. And the way I'm going to do that is using SQL on demand. So SQL on demand utilizes that SQL runtime I spoke about earlier, but provides an interactive query service directly on data in Azure storage. It does this using what we call a serverless architecture, so where we only pay for the queries that we execute without having to perform any kind of heavy processing on that raw data file I just looked at. It also provides data integration with a number of file formats, so we can query, but we can also output data as and when we require. So once we've got that data loaded into our data lake, we can ask some of the questions on it using SQL on demand. So things like, how many flights are there? So how many flights were there in 2020? How many were in previous years? Does it look like COVID could potentially have had an impact on it? And this is pretty useful because it can help us decide if the data is actually useful before we load that into our warehouse. But we can also get some pretty useful preliminary insights. So let's do just that. Here we were looking at that December 20 data, and now I want to analyze this in a bit more detail. So before I hit preview, now I'm going to use a SQL script. You can see I've got other options, so I could load that into a data frame to use the Apache Spark runtime, but here I'm just going to use SQL script. I'm going to select the top 100 rows. It automatically generates some code for us, and we have an option to connect to either SQL Pool. Now SQL Pool's loading because that's scaling up in the background, and you can see that status there, so scaling up. But also here we're connecting to built-in, so essentially SQL on demand. It also generates a select top 100 star, and it's connecting to that CSV file. If I hit run there, that will execute directly against that CSV file. That will allow us to have some preliminary analysis, so we can see again that data we saw in preview, but the column headers aren't in the first, I guess are not column headers, they're in the first row. Now we have IntelliSense within SQL on demand or in the SQL interface. So if I wanted to do that, I can just start typing first and first row. I know that's the right command, equals 2. We'll execute that again. And now we should see that kind of the column headers have disappeared. C1, C2, not overly informative, but we can at least see, at least we're now looking at the actual number of flights. And if we wanted to see how many flights were running in the US in December of 2020, we can just do a count star, run that, and that will run for all of December 2020. So 371,000 flights flew throughout the duration of that month. If we then wanted to explore all of 2020, so we can start modifying this to start searching through our entire data lake. So if I wanted to see or show you how many flights flew over the last 15 years or so, that what we're treating as our current data, I can just replace these all with stars, and that will search through all of the CSV files in this directory, basically the ones that are storing those monthly files for the US flight information. And I'll hit run. This will take a little bit longer than the 6 seconds we saw before because it's traversing quite a lot of different files. I won't do the maths on the fly, but I guess quite a number of files and quite a number of total records. So when this loads, probably about 25 seconds, 17 seconds, decided to prove me wrong. So just under 73 million flights have run, so essentially 73 million records that we're looking at, and it's been able to aggregate that in 17 seconds. Now we want to modify this query a little bit further so we can start getting some insight. And what I'm going to do is move to a SQL query that I've created earlier, just because I think it's probably easier to see, and you don't want to watch me write an awful lot of code either. So here, what we've done is essentially taken that same auto-generated code. What we can do with SQL on demand is apply some structure. So here, the with command, applying some column headers, but also some data formats as well. And all I want to do is be able to analyze for all of those files. So for all of the data from 2009 to 2020, what are the flights per year? You can see I've run this before, but to prove I'm not lying, I'll hit run. It'll take maybe 15, 20 seconds to run. And we'll see for each year how many flights have run in the US, and we'll be able to see a trend of that information as well. So hopefully it will prove me wrong and go a bit quicker. There we go, 18 seconds that time. And we can see that in a tabular view. You can see I've got the option to export results. So if I wanted to put that as a CSV file, JSON or XML, I can export that information. Or more usefully for the purposes that we're running through here, we can see that in a graphical form as well. So I've got different chart types. I'm going to use this kind of default line here. The category column I want to be year. And then we can see the total number of flights. We can see how that trend has varied over time. So quite a lot in 2009, 2010, dropped off a little bit, and then a sharp increase from 27 to 2018, and a little bit of an increase to 2019. But I guess as we suspected, there's been a pretty large drop off in flights in the US for 2020. Now here, what I want to do is start to understand that in a little bit more detail, I guess at a daily level within the US. So I'm going to just switch over to analyze the 2020 flights. And here, I'm just going to look at the first, I guess, 5 months of the year, because when Andrew takes over in a little bit, he's going to try and predict what the rest of 2020 will look like for us. So we'll just look at up to May and see, I guess, what the difference was. So here, just looking at a date level, let's have a look at the number of flights. I won't rerun this because you've seen it all run in the last demo, but at a day level, the number of flights for all of 2020. And we can again see that in a chart format. I'll choose FL date because that's the date. And we can see pretty standard pattern, I guess, between weeks and weekends, the number of flights in the US. But then around kind of mid-March or end of March here, starting to drop off pretty significantly. Now, I roughly know that's when COVID cases started to increase in the US. But let's see if we can see that correlation. What I'm going to do here is, I guess I could look through my COVID data to try and see how we can combine it in SQL on demand. Now, if I go back to the top level here, airline, I can find that COVID folder. I can look at the COVID cases in the US, and we can preview that information. And what you'll see is we have a slightly different date format. So it's not going to be the easiest thing for me to combine that data together. And I'm already pretty confident by this stage that there is going to be some kind of correlation between US cases, COVID cases, and the number of flights running in the US. So I'm going to take the plunge. I'm going to load that data into our data warehouse. The way that we're going to do that is using the Apache Spark runtime. And we're going to do that in the form of Synapse notebooks. So here we can quickly configure and run multiple essentially notebooks using multiple programming languages to perform both data engineering and data science operations on our data. So we can do that in languages such as Python, Scala, SQL, and C#. And we have some options depending on the scale of the operations and workloads we're running to scale that up and down, as I kind of showed in the management area earlier. And this is also going to have some tight integration with the data pipelines that we'll look at in a second for when we want to productionize this and run it on a daily basis, potentially as we see new flight data coming in or the COVID cases changing as well. And what does that look like? So again, if we look in our develop area, we're in data at the moment. If we look in develop, we have a number of notebooks. And what I'll do is open the notebook that we've created for this purpose. So I'm not going to run it. I ran this yesterday, but essentially what we're able to do here, I guess, using PySpark as the default language, using that Spark pool that we've already created, run some data transformations and load that into our SQL pool. So here, using that same pretty similar code base to, or pretty similar code to what we used before, load all of the CSV files in our current folder. We can see what that looks like. So we've loaded that to a data frame. We can see what the information looks like in the data frame. Pretty much what I was expecting, so happy with that. And then we can write that information to our SQL pool. That's what this code is doing here. Then from a COVID perspective, so again, we want to load that COVID USA case data that I looked at before. We can see that on a, I guess, day-by-day basis, the number of cases within the US. And then we can also then perform some data transformation and manipulation here. So the ability to essentially change that date format, so format it in the same way that we have our US flight data. And then again, we're going to just load that into our SQL pool. Once that's loaded into our SQL pool, we can then go and see that data available in the data tab. So if I go back to my workspace, we have all of the SQL pool information. I've loaded that into my current data and also my COVID information as well. And then I've written a pretty simple query that's going to allow us to analyze the impact of COVID on the number of cases in the US. So here, just looking at combining those two data sets together, we're looking at everything, I guess, less than 5, so everything from between January and April. So Andrew can do some prediction for us in a second. But if I run that, it should take just a couple of seconds to combine all of that information together. So a little bit quicker than SQL Pool, because we've got that performant warehouse now running all of the processing of data. And we can see that in a graphical format as well. I'll change this just so we can see that by the date, so we can see the number of cases. As soon as they start increasing in the middle of March, we can start seeing I guess it reaches a critical mass at this point, and the number of flights in the US start decreasing pretty dramatically. So what I'm going to ask Andrew to do in just a second is see if he can predict what the number of cases going forward will look like. One thing I wanted to show just before that, I've had some queries here that show the biggest delays for airlines and doing a slightly more complex SQL query. So I ran this earlier against the kind of DWU 100. So a relatively small data warehouse. It took 32 seconds to run. After that scale up that we did, it's run in 3 seconds. So just showing how we can use SQL Pool, we can scale it up and down. If we need, 3 seconds to return this information, then we can get that kind of performance by simply scaling up and scaling down SQL Pool. So I just wanted to show that on the side. But Andrew, why don't I hand over to you and you can take us through how we can start forecasting the number of flights based on this information.
Okay, so James has taken you through how to build the data loads in Synapse, and you've looked through the notebooks already. And that is one of the key options for us when it comes to building out your machine learning within Synapse. So there are a few different approaches. The first of those builds on those notebooks, and one of the languages supported is Python, and also some of the Spark capabilities enable a level of machine learning as well. So whichever of those languages that's available you want to use, there are hooks into machine learning. So in particular, Python has a whole load of libraries, and all of those are available to you to use alongside the data that you've got in Synapse. The second option is to use ONNX, which is Open Neural Network Exchange, and that's an approach to building and sharing particularly neural network models, and that will allow you to build the models in one tool and transfer them across so that they can be used to make predictions in a different tool. So you could do the training in any number of tools, whether that's another Python instance, or build that using the Python notebooks even. Or there are a wide range of platforms that support ONNX, so it's not just Synapse, but the same models that you would be able to use in something like AWS or SaaS, and you can port those across onto Synapse. Once you've loaded those into the SQL pool, it offers up a predict function that could be used within stored procedures. So if you're building out your SQL queries, you can put predict functions in those and do it all natively within the Synapse Analytics database, so that all that great skill that you're getting, large volumes of data, fast calculations, we can use that to build out some of our machine learning capability as well, using that standardized ONNX model format. The final option is tight integration between Synapse Analytics and Azure ML. Use the data from within your Synapse Analytics platform and bring that in with Azure ML, and that offers up capabilities like building your machine learning models using drag and drop functionality known as Azure ML Designer, or other options like orchestrating the machine learning components with Azure ML, automating the pipelines, automating training, and so on. So whichever way you want to build your models, there are a few different approaches that you can take within Synapse Analytics to do that. I guess to give you a flavor of what it looks like in the notebooks, the easiest thing is for me to switch across back into the Synapse Studio. So this is the same studio that James has been showing you already. Open in the browser, and we've got here a notebook that, as you can see at the top, loads in from a number of different Python libraries. So we're going to mixture of PySpark, and also I'm using some kind of standard Python here. So if you're building this out to do something that's at massive scale, particularly for the training, typically you might want to use something like the PySpark functions. But equally, if you've got a data set that you want to pull out and use the flexibility of everything that's available in Python, you can bring that in here as well. And in this case, we're using the stats models package. So that will give us a wide range of statistical tools that we can apply to the data here. And so we're doing that using a combination of Spark SQL. So we'll pull everything from the airline table that James has been building up for us. Like we say, he's built up to, I think it's April. And we can do a bit of data transformation on that, but ultimately what we want to do is create a forecast that goes out beyond that date. So to do that, I've written a collection of Python scripts. So some of this is doing statements that are doing data transformation. We're able to do some quick things here, like converting the day to a date time that can be recognized by the forecasting functions. Here we're able to kind of aggregate up and make sure that for every day in the pattern, we've got one kind of aggregated number of flights that took place, and then we'll plot that. So you can see here there's a Python plot, and we're able to just view that alongside the code in this notebook. So it gives you a really flexible format. Some people will be used to the likes of Jupyter notebooks and so on. Very similar approach here for machine learning. So you can see the data as you're building it up. Take the daily level, aggregate it to the monthly level. So resample at that stage and then plot it again and check. So all of those kind of ups and downs that we're getting in each individual day, probably indicating days of the week or whatever, we've taken out. What we're interested in at this stage is, can we spot a pattern across the months of the year? So we want to smooth it out a little bit by taking it to the month level. And then we can look at statistical measures. So here we're just taking a fairly simple first view. What's the rolling mean? What's the standard deviation on that? So we can see the rolling mean here charted by the red line. So again, some of those peaks, troughs that are coming about just by the natural variance of each month, we're able to see a growth over a period of time and then a slowing before we have this drop off. So you can see the standard deviation is falling for a bit, and then when we have that drop off, you see the standard deviation gets much bigger. So we're able to get the kind of statistical measures of what's going on here. From there, we'll actually build out a model. What we're doing in this case is looking at something that takes a level of seasonality by looking at autocorrelation. So we'll take the autocorrelation plot here, and it's looking at that from the monthly level, but trying to get the patterns that are going on. And we can plot that here, get the various different statistical plots that we want from Python, and ultimately then we're going to plot what are our fitted values and what is the prediction that we're making for the number of flights going forward. And once we've done all of that in the notebook, so you do that very interactively, seeing the visuals, writing the script as you go, and running it on the data from Synapse. Once you've done that, you can write it back into Synapse so that your forecasts, your model outputs are available to anyone else who wants to do further analysis with it.
Thank you, Andrew. So I thought I'd also just show, I guess, what actually happened in the US throughout 2020 in terms of the number of flights versus those COVID cases. So as we all know, the number of cases in the US did increase. But actually, quite interestingly, I guess, beyond coming towards the end of June, it doesn't continue to drop off, I guess, like Andrew predicted, but it kind of stabilizes at a much lower point than where we were before. But there is, there are 10,000 or so flights from what we had 20,000 before, so about half the number of flights running on a daily basis within the US. But anyway, if we now want to look at, as Andrew said, how we can productionize some of this, make sure it runs on a daily basis, we can load the data, make sure it's in SQL Pool ready for our analysis, then we're going to start using, I guess, the final piece in our develop area, so the pipelines and the ability to orchestrate workloads. And the way that we're going to do that is with essentially Data Factory, so orchestration. So Data Factory is a cloud-based data integration tool that allows users or us to create data-driven workflows in the cloud that orchestrate and automate the movement and transformation of data. So we could ingest the data, so we could ingest those CSV files using Data Factory and then run those notebooks that Andrew and I have created to load and then analyze the data in more detail. It does have some integration with something called data flows, so that kind of point and click interface that we can create data transformations with. But essentially in this use case, and for a lot of use cases, we use it to orchestrate the movement of data. This could be based on events, so when a new file is created, that it will run the loads. So every time we get the monthly flight data, it will run all of the end-to-end data loading and transformation, for example. I'll just show a very simple, I guess, pipeline here that we're using to load all of that data from the data lake into our SQL pool. So here, just load airline dimensions is what we've called it. So here it loads all of that kind of metadata information. So we saw the codes in the underlying data, but that has things like the airline information. So whether it's Southwest or American Airlines, that kind of information. It then has that direct integration with the notebook. So I can call the fact data notebook. That's going to load my COVID cases and load all of that current information into SQL Pool, and then it does some copy activities. We have the options for things like triggers. So if, as I've said in that kind of example, if a new monthly file of US flights come in, or we want to update the COVID data, we can create triggers, triggers based on events. So as soon as that file is created, so it can run on a schedule, it can run every day, or a storage event. So if a new blob is created, so essentially a new file is created, then it will trigger this workload as well. But we can use that to essentially orchestrate all of the, I can't even move my picture there, orchestrate all of the flows of data within Synapse Analytics and use it for our analysis ultimately. So what I want to do is just kind of summarize what we've walked through in today's session. So we've covered quite a lot of information around Synapse Analytics and how it really enables us to get a single lens that we can use to essentially store data, so store different types of data, be it structured or unstructured data using Azure Storage, the ability to develop using a number of different runtimes, so the Apache Spark runtime or the SQL runtime, but also in a range of different languages. So Andrew and I use PySpark, but we have a number of other options available to us. And then the ability to essentially productionize that, so using the orchestration, using those pipelines at the end to run our loads on a schedule, run them based on an event, and essentially bring all of this together so we've got an up-to-date environment that we can perform seamless analysis and ultimately get the value from our data. Underpinning that, as we kind of covered, we have the ability to monitor what's going on. So what queries does James run, what queries does Andrew run, but also manage that as well. So we can pause the SQL pool now that we're no longer using it. we can scale it up and scale it down as we need to, and we can do that the same thing with our Apache Spark runtimes as well. And of course, things like security and the wider things that we need to consider in an enterprise rollout. What I wanted to talk about very quickly now is just how to get started with Synapse Analytics, and more fundamentally, how to get started on your cloud journey if that's where you are as well. So I'm going to start off with, I guess, a more philosophical question that applies generally to the cloud journey. And that first question is kind of how do we move to the cloud? So if you're not using Synapse, you're not using Azure, how do you get there? And the answer really is it falls on a spectrum. So at two extremes, you have the option of just taking your existing systems. You could lift and shift, even just move things like the existing architecture to what we call infrastructure as a service hosted on the Azure cloud. And pros of this option are things like you can realize the benefit of cloud quickly, such as services being managed for you, and you can do that pretty quickly. Alternatively, you can completely reimagine your data landscape and unlock the full potential of new cloud-based and cloud-born offerings, so like Synapse Analytics that we've looked at today. We call this the innovate approach. So the benefits are that you can forget all of the constraints and realize the maximum value of new tools and tap into those new data sources, structured, unstructured data, for example. More likely, you'll land somewhere in the middle, though, between these approaches. So lift and shifting some structures and creating brand new assets in cloud offerings like Synapse Analytics. I just wanted to highlight this as a critical decision to make pretty early on in your cloud adoption strategy. Now let's talk through some of the key considerations when we move to cloud or adopt a new tool such as Synapse Analytics. One of the big things that you need to think about are user education and empowerment. So sessions like today are helpful to learn about the host of kind of tools available within Azure and what Synapse Analytics offers, but we do recommend more in-depth training for your power users and developers and kind of getting up and running with these platforms. And then maybe empowerment programs, because we can load all of the data, all of the insight into Synapse Analytics, but if people can't use them, we really need to be able to get people kind of gaining insights and leveraging the tools that we're creating. But I think the most important thing is to get started. So the delivery of business solutions, ensuring value is the driver behind the technology. So what are your use cases? Making sure that it's aligned to the technology and really maximizing the outcomes as a result. And as you get started on this journey, Thorogood can help you guys in a number of ways. We can help with things like the initial strategies and understanding how you can use platforms like Synapse Analytics to unlock value in your business. And then we can take that a step further and help in the delivery of business-focused applications by running things like proof of concept right through to the end-to-end delivery of solutions. And then we can help with the adoption of the platform as well. So through enablement programs, but also the wider support of those applications. So with that, I wanted to end the webcast by saying a big thank you to everyone who's joined us today. I hope it was useful, and we look forward to hearing from you all very soon.